hitting record on this computer. And what happened last time is we took a test. So I'm getting stuff graded and turned around. Try to do it this weekend and get some letters sent out. That said, I am glad y'all are here. I don't know what the heck some students in this class are doing, but I definitely don't suggest doing what they're doing if you want to stay and pass this class. So I was hoping, like, I don't know. I feel like I'm behind on the grading, like, pretty bad. And, like, part of that's probably me, but, like, another part of that is, like, I just did not expect grading to take this long. When I spend class time to go through the homework and, like, show you how to do the homework and give you solutions to the homework, I kind of figured people would just, like, have the correct work there. That was maybe a flaw on my part. I don't know what to say about that. Some people, I don't know what they're turning in. It's like I'm playing Snake to, like, find their work on their test, and it's like, man, like, do y'all want points for this or not? Because that is not a good way to, like, get points on anything. And I'm probably preaching to, like, the choir here. I think y'all are doing, for the most part, what you're supposed to. But yeah. It makes it so much easier if everyone just puts the right answers. So that's what I'm going to encourage you to do. Just do all the right stuff on everything. It makes me a lot happier. I don't like to put bad grades on people's stuff. It makes me feel really bad. I've gotten bad grades in my college career. It didn't feel good. I didn't always pass my classes as an undergrad. So I think a lot of times people take it personal. It's like, it's not personal. I don't know if that makes it better or worse, but it's not personal. I'm just looking at the work and grading what I see. So this is a horrible joke. But if you've seen Dumb and Dumber, he follows that girl around, and then he asks her, like, what are my chances? And he's like, 1 in 100, and she's like, no, more like 1 in a million. And he's like, gets so happy. So you're saying there's a chance, So Lloyd is really horrible with probabilities, is what the point of that little thing was. And don't be like Lloyd. Be better at probabilities. But we're going to talk about probabilities today. So we jump to chapter 7 now. Chapter 7 is going to be all about probabilities. And so we're going to do probabilities here in A. We're going to do combining probabilities in B. C, I think we get to the law of large numbers. And then D is some infographic stuff, I believe. Could be wrong. That could be in chapter 5. Chapter 5 is statistics. So right after we do probabilities, we're going to do statistics. They kind of go hand in hand a little bit. Okay, so what do they ask first? A restaurant has a special menu. So I talked about this and the notes a little bit, but, like, if we have, here's a city, here's a city, here's a city. This is going back to the, like, what I think what they call sometimes simple counting principle. Yeah, they're already answering. But if I have, like, 2 roads here and 3 roads here, and I think about how many unique paths I can count between, like, city, I don't know, let's call this A, let's call this one B and C, something like that. So if I want to think about, like, all the unique paths from A to C, city A to city C, I got 2 roads going from A to B, I got 3 roads going from B to C. You might notice you go along this first road, there's 3 different routes taking this first road. So we go the first road, there's 3 different routes. We go the second road, there's 3 different routes. So you might figure out there's like 6 in all for this thing. And so if you think about that, there's 2 roads here, there's 3 roads here. And so basically the simple counting principle says if you have 2 options here and we got 3 options here, what we're going to do is we're going to end up multiplying them to get to a total of 6 different options. And so that's kind of what we're doing here. Y'all are already answering. You probably already know this. But here we go. Clear my drawing. Clear this. Get out of here. What'd you tell me? Good job. And so just to sort of break down what you did, hopefully, you think about each option. So this is a lot of times what we do. We do like salad and put a bar above it. Think about how many options. Option 1, option 2, option 3, 2 times 8 times 6. I think I mentioned it in the notes or something, but when I was in high school, I worked in Whataburger, and they had that sign out in front. There are so many ways to fix your Whataburger, and they gave a number. But the easiest way to do that is if you think about each option, you multiply by 2. So you either have ketchup or you don't have ketchup. You either have mustard or don't have mustard. You either have mayonnaise or don't have mayonnaise. So each thing you're going to multiply by 2. I was thinking about it. It's a little bit weird because you also have the option of not having mustard, not having mayonnaise. Here we kind of assume you're going to make a salad, you're going to make an entree, you're going to make a dessert. If we said you have like the option of not having one of those, you could always add one to this, right? No salad would also be an option, no entree. So you could fix that maybe on here. The thing that's kind of weird with the Whataburger though is you can have combinations. We're assuming you're not doing multiple salads or multiple entrees, multiple desserts. With the Whataburger example, you can actually have those combinations. So if you think mayonnaise, mustard, and ketchup, and you try to do times 3 or times 4 for none of them, you're going to miss the combinations of mayonnaise and ketchup. You're going to miss the combinations of mayonnaise and mustard and ketchup and mustard, right? So I think there should be like 8 options or something. 2 to the third. So it's easier to do it by the is it included or not included sort of thing. Probably more than you need to know there, but actually come in handy one day maybe. Use a theoretical method to determine the probability of the following outcomes in an event. State any assumptions that you make. So I know I changed around some of these. I don't like the way the book does the examples with the boy-girl example. I don't agree with the dichotomy. There are people that aren't just boys and girls. And the boy-girl thing, it's not 50-50 that you have a boy or girl either. It's like that's an assumption they're making. That's not true. And so I think it changes to flipping a coin, because flipping a coin gives you the same thing and it actually gives you 50-50 shots. So I changed 2 of these problems from what the suggested homework was. So use a theoretical method to determine the probability of the following outcomes and events. State any assumptions that you make. So I don't need to do that. But if we randomly flip a coin twice and we get heads twice, what is the probability of that? And so my suggestion is to write out your full possible outcomes, write out all the possible outcomes, and then figure out how many of those you have. Or how many of those are getting heads twice, right? And this should either be like a reduced fraction. I think I also put the decimal in there. Oh, this is lagging, huh? Get out of that. Yeah, it's figured we all answered that. What's happening? That's weird. It didn't go forward. Okay, all right. And so it should be, yeah, there we go. 1 out of 4. And so hopefully this is what you're doing. If you're flipping a coin twice, these are all the possible outcomes. I'm either getting heads twice, I'm getting heads and then tails, tails and then heads, or I'm getting tails and tails. And so the way that you figure out probabilities is you do the number of times that something occurs divided by the total number of observations. And so I'm looking along here, I'm looking at this heads happens once out of 4 times. Questions? I think we're getting this, huh? Did I mention? I mentioned it in the notes, but like one of the guys that really pushed forth a lot of these probabilities and a little bit in statistics was a Italian guy named Cardano. He was like a big time gambler. So probably not very surprising that someone that was a gambler is also studying probability. But did a lot of good development. I don't suggest. It took me a couple years after I got my degree in statistics to want to enter a casino, if I'm being honest. I've been in a casino a handful of times. I mostly do it to go to look at a light show. I figure like go play a video game and lose some money, basically, is what I'm gonna do. Like going to an arcade almost. Except you can plan on losing the money most of the time.
Do you want us to run to how many places?
Oh, so for this, I think I rounded to 2 places, but you should really give me the fraction, and it should really be reduced.
Oh, okay.
Yeah, if you can do a perfect fraction, that's kind of preferable to a rounded decimal, typically. Okay, so local weather forecast has been accurate for 15 of the past 27 days. Based on this fact, what is the relative frequency probability that the forecast for tomorrow will be accurate? Yeah. No. Got a moth trying to get in my coffee. One of those little mayflies over there. Gross. Okay. Okay, so this is a different one. Okay, I just skipped right past it. So the thing about theoretical probability versus, what do they say, relative frequency, I think is the other one. And then the other third one, I don't even like. It's called speculative or something. It's silly and stupid. I'm never going to ask you that. Like, you shouldn't speculate about statistics, really. It's like, well, I think he's not going to get married or something is what the book says. It's like, I don't care. Like, give me some real numbers. The big difference between what theoretical and relative frequency was like the theoretical, we're making assumptions about things, right? This was something that already happened. 15 for the past days, right? These were things that already happened. We observed them. It was like an experiment or something that already happened, and we just go look back on the data. So for frequency, relative frequency, we're looking back on things. We're not making any well, I guess we are. They're making predictions about what's going to happen, but they're basing it off of data that's already happened. When we do theoretical probability, we are making assumptions about things. We're saying things are equally probable. When I roll a die and I give you the probability, the theoretical probability, I'm making assumptions that that die is a fair die, that is equally weighted, right? It's not going to, each side is equally likely to come up. And so for this one, we want to make a probability distribution for the given set of events. We're going to make a table. You can make a table or graph or both. The sums that result when two fair four-sided die, they call them, I guess, tetrahedrons, are tossed. List all possible outcomes is my suggestion. And then you want to find the sums. So a little bit about how to organize this. I think I did it in the notes. Like you're going to want to create maybe a table to find the sums. And so this is going to be our sum table. So if we look up here, if we toss the first die, we basically have 2 dice here, right? If we toss the first die, we're going to get a 1, 2, 3, or 4. If we toss the second dice, we're going to get a 1, 2, or 3, or 4. And so right here, if you look, this would be like getting a 1 and a 1. This would be like getting a 2 and a 1. And so you should be able to fill this thing out. Make a little sum table right quick. And if you do this, this will really, really help you with your probability distribution table. I think you get the same thing here, right? 2, 3, 4, 3, 4, 5, 6, I believe. 4, 5, 6, 7. So I think it should go from 2 to 8. Do you understand what I'm doing? I think. Do you think you can do this?
Yes.
All right.
So,
what was that? I missed it. Sorry.
well, I just said I'm currently working on it.
All right. So finish this table out. It should look, I think I got it on the next slide. Should look something like this. So like I said, we're going to get a sum. The lowest is going to be 2. The highest is going to be 8. And so now we want to figure out the probabilities. And if you make this table, you might notice a little pattern up in this table. I'm going to get 2 once. And so that makes my probability 1 out of, how many are going to be here? 4 by 4. Give me what?
16.
Yeah, it's 16. So I have 1 out of 16. What else? The next thing I want to do is 3s. You notice anything about 3s? You can look diagonally here, right? If you look diagonally, I think you notice they all have the same sum. So if you do this table, it helps you out quite a bit, hopefully. And then you might notice a little bit of a pattern in this thing, maybe even. I have 1 out of 16. I believe I have, 2 out of 16? I have, 3 out of 16? Does this seem like something that's doable, hopefully? And I think I go 4 out of 16. All right. So hopefully you can make a probability distribution table. And this is one of the ones that I changed. I think this is 41. And I think they said to do 39 or something like that. But I feel like this is a better question anyway. I did this with the 6-sided die in the notes, I believe. This is good practice. Hint, hint, try to put it in there. But you should be able to do something like this. And so let's look at the next slide. It's filled out. And so I said you should really reduce them, but sometimes it is better to not reduce them, if I'm being honest. And if I want to look at this, I want to get this point across. So if I add all these up, if I sum up everything, let me grab it with the draw. If I sum up everything here, all my probabilities, if I add them up, what is it going to add up to? And this is kind of goes back to, we probably don't want to reduce them because it's easier to add 1/16 and 2/16 than to try to add something with a different denominator. You know, do yourself a favor and keep the same denominator. So what are these going to add up to? 1, 2, 3, 4, 3, 2, 1. Add all this up.
Would it equal to 16 out of 16, which equals 1?
Yeah, and so that's 1. And so I didn't, maybe I skipped this earlier, didn't I? So when we talk about probabilities, probabilities run from 0 to 1, right? And so if I say there's zero probability that this thing is happening, that literally means there is 0%, right? It means like there's a 0% chance of this thing happening. If I say there's a 1, like the probability of this thing happening is 1, that means like 100%. So we talk about probabilities. They're kind of like talking about the percent that something's going to happen, right? It's the chance that something's going to happen. It's the decimal of the percentage of the chance that something's going to happen. And so when I look at this and I sum up all the probabilities and they sum up to 1, what is that telling me? These are all my possible outcomes, right? So if I sum up everything that's could possibly happen, something is going to happen, is what this is telling me. Like one of these things is going to happen. I'm either going to get a sum of 2, 3, 4, 5, 6, 7, or 8. So I'm guaranteed to get one of these sums. So this is everything that could possibly happen, is what this is telling me. Does that make some sense, hopefully? Yeah, if I sum up the probability of everything that could possibly happen, I should get up 1 because it's guaranteed something's going to happen if I roll 2 dice. Okay, these are kind of a weird sort of vocabulary sort of thing. And to be honest, I got to brush up on it whenever I go to this section. I think I'm getting it down now that I've taught it like 3 times now, I think. I put this in there. I didn't always have this in my lesson. So use the definition of odds in betting to find the following odds. The odds on or against your bet are 3 to 5. If you bet $20 and win, how much will you gain? So this is the sort of hint that I gave. So when we read odds backwards. So if I bet $5 and I win, excuse me, I'm going to win $3. And so I put $5 down. I should win $3. And so when I go to the teller to get my money, he should give me back my 5 and he should give me back 3. So I should be getting $8 back if I gave him $5. Okay. So there's a few different ways they can ask this question. They can ask you maybe how much are you going to win, or they can ask you how much should you get from the teller. You have to be careful sometimes how they ask this. But what I say, for every $5 we bet, we're going to win 3. So if we play $20, and so this is the amount that we're betting. So hopefully you're thinking I'm going from 5 to 20. How do I go from 5 to 20? What will I receive in prize money? So if for every $5 bet, I'm going to get $3 in prize money. If I bet $20, how much would I get in prize money? There's a few ways to do this. It should be dollars amount.
Wait, I have a question.
Yeah, what's up?
So after you find it, do you add the money you betted back?
No, they're just looking for the prize money off the top. How much are you going to net or benefit gain, or not, or what is the amount that you're going to come out ahead? So go from 5 to 20, we're multiplying by what? 4? Yeah, y'all got it. You multiply by 4. You get $12, I believe, right? Is that we already getting? Yeah. What are you telling me? Oh, you added it. Okay, that's fair enough. Yeah, that's what I was talking about. You have to be careful with the way that they're doing it. I know where you're coming from. See, I would have said 32 almost. too with the way they're asking it. Because if you go to the teller, they should be giving you $32 because you should be getting the 20 you paid, and you should be getting the 12 back. What is this? Decide which method, theoretical, relative, or subjective, is appropriate and compute or estimate the following probabilities. If you use the subjective method, explain your reason. Don't use the subjective method. That's the thing I said don't use. Not hearing your favorite group on a random shuffle of your playlist that has 889 songs, of which 127 are by your favorite group. See, I don't know if I answered this one right, if I'm being honest. They didn't have the solution in the back of the book. And I don't really feel like it's worded very well. So if you just want to hit something out, we can talk about it maybe a little bit. I can talk about why I thought it was what I thought it was. And I can talk about maybe why they thought it was what they thought it was. I'm going to almost guarantee you're going to probably just say the other thing that I didn't say. Yeah, they're probably going to tell me relative frequency. Oh, who said subjective? I told you not to do that. What is this? Chart view, full question view. Why is it? So what does it say? Not hearing a group on a random shuffle of your playlist that has 889 songs, of which 127 are by your favorite group. So I said theoretical, I think, but a lot of people said relative frequency, which I could see, because you're looking back at your playlist and looking at the number of songs off your playlist. But I think it's theoretical because we're making assumptions that each song is equally likely to be played. It seems like there's some assumptions that are being made, but they're both found the same way, so I don't think it's really that big of a deal. And so they want to know the probability of not hearing your favorite group when we have 889 songs, 127 are by your favorite artist. So not hearing them, if you wanted to hear them, I would be 127 out of 889. That's not what they're asking. So I think the first thing you got to figure out is how many are not by your favorite artist. So if 127 are by your favorite artist, and we have 889 total, and I think I rounded this to 2 decimal places maybe, or fraction, or you do reduced fraction. Do y'all know how to do reduced fractions on like your calculator? I showed the other class. A lot of calculators allow you to get a reduced fraction if you do it right. I'm going to clear this. Okay. Let me share this. Ooh, excuse me. I'm going to share my TI Smart View up in here. All right, so what we're doing, 889 songs total. And there were 127 that were not from your favorite artist. 8, 2, 7. What happened to my 2 key? 762 should be the number that are not your favorite artist. So if you do 762 divided by what? 889 would be the probability that you're not going to hear your favorite artist. That is a decimal. If I want it to be a fraction, on the TIs, it is the math key, and is that first option, frac. That's where it's found on the TIs. This is a function that's like, it's on a lot of calculators. You can go from fraction, or if you want to go back to your decimal, you can go back to your decimal. But it's a really quick way to get reduced fractions. Did we answer this? Let's go back. I think I already gave you all the solution, didn't I? Quizzes. Probably me that didn't answer it yet, huh? Totally me. All right. And my quizzes is frozen now. Come on. My internet connection is unstable, but that's it. I really think it probably should be relative frequency the more that I look at that one. Not hearing favorite groups is what we just did. Hey, 89 to minus 127 gives me 762 that aren't my favorite group. I divide those, I get 6/7. It's getting warm out. Okay, that's a little better. All right, so what are we doing now? The marbles. I'm gonna lose my marbles. Suppose you reach in and draw 2 marbles at random from a bag containing 10 white marbles, 10 black marbles, and 10 red marbles. This is where I say list all possible outcomes for this process. So this is what I did. I would start out with 2 whites, and then I would do everything where white can be first. White, 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 black, white, red, and then I do everything where black can be first. I do black, white, black, 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 red. And then do everything where this one can be first. So I believe you should get 9 different options. There, I'm seeing that. Let's see how long it takes to type in.
So you just put all the possibilities in the
Yep,
answer?
yep. That's what they're looking for. Every possible outcome. There should be 9 of them. Black, red. Okay. So we got a bag of marbles that's got 10 white, 10 black, 10 red. I'm going to draw 2 of them out. So it should be combinations of 2 letters, every different combination. It should be 9 in all.
Do you want us to type that in for the answer?
Do you have it?
Yeah.
That's fine. I'm just gonna end it then. So hopefully this is the sort of pattern I was talking about. Oh, we had that counting principle back when we did logic, the trues and falses. I don't know if you remember that, but the 2 times 2 times 2. We had 2 propositions. We had 2 times 2, 4 different possibilities. We had 3 propositions. 2 times 2 times 2 was 8, right? So there's a similar thing here, right? If we have 3 options for the first marble, 3 options for the second marble, we got that counting principle. 3 times 3 gives us 9 total options. And so like I was saying, this is the way I kind of broke it down in my brain when I do this pattern. I start with all the white marbles first. White, 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 black, white, red. And then I go in this pattern, white, black, red. I just do the pattern they gave it to me in. So this one changes. Now I do everything with black. Black, white, black, 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 red. Now I do everything with red. I think that's what y'all got, right? Hopefully. And they say what? Make a table or graph showing the probability distribution for the events of 0, 1, and 2 black marbles. This is where I need to jump back. I want to do some text. What is it? Like event is what, like 0 black, 1 black, and what? The most that you can have, I believe, is 2 black, right? And then here's my probabilities. So I want to make a table, probability distribution. I can't even speak. Probability distribution table for this thing. And so I'm thinking along here. I want to do everything that has no blacks in it. This one has no black marbles. This one has no black marbles. That one's got one, that one's got one, that one's got one. This one's got none. This one got none. So this is what I'm hoping you're seeing here. This is what, 4. I think I said this is out of 9. Does this seem like something's doable, hopefully? And so then basically everything without a B in there is what I'm going to go circle. Now I'm going to do everything with 1B, exactly 1B, right? So it's got to have exactly 1 black. This one has 1, this one has 1. So I don't circle this one because it has 2. I circle, I believe, this one and this one. So I think I should be getting the same thing here. There's 4 of them out of 9. Sloppy, but there it is. And the last one, ooh, getting really sloppy apparently. Trying to do it with my computer pad instead of just typing it in. But there we go. There should be 1. And again, if we look here, if we draw 2 marbles, we're either going to get nothing that's black marble, we're going to get one of them that is a black marble, or we're going to get that instance where 2 of them are black marbles. So if we look again here, these should sum up to that good old thing of 1, right? 4 eighths, or 4 ninths, 4 ninths, and 1 ninth gives you 9 ninths or 1. And so I think I did it all here. Oh, where's my, let's clear all this. I believe I got my table on the next thing as well. Next slide, come on. This is an open-ended draw table question, huh? I don't know why I put this on here. To give me time, I think. And so I believe this is what we found on that previous. Questions about this thing? Going quick today. Okay. If I made you draw a graph, do you think you could draw a graph of these sorts of things? We do event down here. I can't even spell good. We do a graph, right? It should look something like event goes over here and my probability goes over here. And so if I was thinking like a really rough graph of this thing might look something like this, and I get something like 4 ninths here. I get like something like 4 ninths here, and I get something about a quarter of the way up, or 1 ninth there. And so this would represent my 0 marbles, my 1 marble, my 2 marbles, something like that. So I know I'm not making you draw graphs, but you should be able to. we will definitely do more next section. Are there any questions over anything we've done so far? Does it all seem pretty doable? It's kind of hard to put some of this into this program. It's like create a table, you know, it's like this program doesn't exactly have that. Okay. Now we have so there's some political convention. They have them sorted by what party? They have them sorted by gender here. And so the following table gives the gender and political party of 100 delegates. And so I didn't realize they told you that there. But if we look at this and we sum up all the people that are there, it should sum up to 100. And so they say, suppose you encounter a delegate at random. What is the probability that you meet a man?
Do we put the fraction or the decimal?
Either way, you can do it just divided by 100, right? Or you're just going to put a. This one is so easy to convert to a decimal, right? They're really nice giving you that 100 people at the thing. That's almost never going to happen. Yeah, okay. So if we want to know how many men, what are we doing? Looking along here. I hope that's what y'all did. Sum up those three numbers. I believe if I sum up those three numbers, it should give me 48. So 0.48, I believe, is what we're doing. Yep. And the next one. So we get a few. Well, come on. Okay. The next question. What does it say? We get a few questions with this table. So what is the probability you meet a Democrat? So where are we looking now? I believe it's linked here. So hopefully you're narrowing it down to the Democrat line. I'm about to hit submit, but whoops. So I believe it's those two numbers in there, right? Will give me my Democrats. I know there's a few different ways to solve some of these that are coming up. Yeah, 0.41, that's it. Oh, why do you keep busting that image? There we go. There's that image again. What is the probability that you do not meet an independent? This is the one. I will say there are at least two different ways to do this. So one way, if you don't want to meet an independent, is you can look at those four numbers and you could sum those. Is that what y'all did? It's probably the more straightforward way. But there's another way if you think about it. If I have 100 people here and what, 10 of them are independent. That's the way I would have done it personally. And so if 10 of them are independent and there's 100 people, it's the other side of that. So if we did the independents, I think it would be 1. We could always remove that from the 100%. That's another way. We could always take 100 and just subtract 10 and get the what, the 90. Where are you at?
My answer is going to be wrong because I only calculated it as if it was asking for independent.
Oh, you're gonna give me 10%. That's, yeah, they said not independent. Yeah. Not me. Those little words, man. Just that little not word always, like, it'll throw you off if you don't pay attention to it. It's like, oh shoot, did the exact opposite. 0.9 is where we're at. Yep. And so you could add those 4 up, or you could just subtract what, those 2 from the 100. So using that fact that everything adds up to 100% can sometimes help you. Because we only had 4 numbers here, right? But we could do other parties, and this could be like, who knows how freaking long this thing could be, right? We could be adding like hundreds of numbers up here, or we could be subtracting 10 from 100. You know, which one would you rather do? So sometimes that really saves you if you have a long list of things and you're like, I want everything that's not this, it's 100% minus that, all right? Okay, what are we doing now? Probability you will meet a male Republican. Oh, this is asking something very, very specific. So if I'm looking here, so I'm narrowing it down with this, anything that I circle here, and I'm narrowing it down with stuff that I circle here. It's got to be both male and it's got to be both Republican. So what falls in there? Exit out of this thing. What are you gonna tell me? 0.28? Yeah, exactly. They're talking about that one number of male Republicans. They're all my drawings. Get out of here. Next slide. I think they do something similar to here, maybe. Oh, come on. What is the probability that you meet? What is the probability? This is the one that I've repeated myself. Okay, so we're looking here. What is the probability that you meet someone who is not a female Republican? So this one, again, there are multiple ways you can do this. So not a female Republican. So if you wanted someone who was a female Republican, this would be, well, maybe let's not do that. I'm looking along the Republican line. I'm looking along the female or woman line. And so if I did want someone that was what, a female Republican, that would give me 0.21. So if I want not that, how do I do it? Does that make sense? That's the way I would do it. Otherwise, you could add up everyone that's not a female Republican. That's the other way. Okay, where are we at? Here's annotations, clear. All right, so I think that's the last question. Do you have any questions about anything? Does everything in here seem pretty doable?
Yeah, I would say the one confusing part's like the bet one. There's
Which
just
one?
the bet one, but it's just once you understand it, it's simple.
The bat one?
Yeah, the one where it's like 3 to 5.
What number was that? You remember?
47.
Cause like the one thing that confuses me is like its wording.
The odds? Is that the one?
Yeah.
Oh, yeah, this one. Yeah, it's basically kind of like you can do these a few different ways. Just some annotations. You're doing 3 to 5, so there's 3 in what prize money for every $5 bet. And so what you're really doing is you're finding like a sort of equivalent fraction for these things, right? And so if I bet now $20, it should be in the same ratio as whatever the heck they give you. But then you have to be careful whether they're asking you for the prize money or are they asking you how much you're going to take home from the teller. Those are two different questions. And so when they say prize money, they just mean how much you're winning, not how much you're getting back or betting from your bet. Yeah, it's a weird vocabulary thing. And like I said, like I don't have this stuff memorized, if I'm being honest. I had to refresh myself a little bit. Because there's odds on or against, and there's odds. There's the other way too, and they talk about it. I don't remember what it's called now, even. But they usually give you your odds with the odds on. Odds against or odds for, I think is what they're called. Is the other way around. Any other questions? Anything you want me to go back over? We got a little bit extra time. If not, that's all I got for you today. I will get grades turned around pretty quickly, is what I plan to do it this weekend. I'm going to hit stop on the record then.